All right, people, we're going to do a little solving equations help for you, a little bit of review and some new stuff. So let's get right to it. So we're going to look at solving equations. And when I'm solving an equation, I want to solve for the variable in an equation. So for instance, this first one, I have x plus 5 equals 16. Now, here's the thing. I could read this out loud. What number plus 5 equals 16? And hopefully we can understand that. But let's solve this. What we want to eventually do is we want to have the variable by itself. Or it's actually got a little 1 here. We don't have to write the 1. So in order to do that, we have to do the opposite operation for this, because we want this to go away. We want this to become 0. So I subtract 5. I drew this balance line because whatever I do to this side of the equation, I have to also do to this side of the equation. That becomes 0. I don't have to write x plus 0. I could just write x. 16 minus 5 is 11. Right? Let's do another one. Now, it doesn't matter what side the variable is on. Right, in this case, the opposite of subtracting 12, so what number minus 12 equals 11? I'm going to do the opposite here. Remember, I want w by itself. It doesn't matter what side of the equal side it's on. I'm going to add 12. That becomes 0. I add those two together, and that gives me 23. All right, let's look at what we do if there's multiplication happening. So 3 times what number equals 18? I do the opposite. This is a little tricky because I want this to become 1 now, not 0. But the opposite of multiplication is division. Divide. That becomes 1y. Whatever I do to this side, I have to do to this side. 18 divided by 3 is 6. So I'm doing the opposite operation in order to solve for these. Let's do one more of these simple ones, or these one-step equations. Let's do m over 4 equals 21. Now this is really division. It's written as a fraction, but it's a division problem. What divided by 4 equals 21? Well, again, I want to get m by itself. I'm going to multiply by the denominator. So multiply. Those two will cancel out. That leaves me with 1m. But whatever I do to this side, I also have to do to this side. 21 times 4 is 84. All right. Well, hopefully that helps out. We're going to get a little bit more difficult because with some of this practice, some of these equations, you have a couple steps to do. And we'll just call these multi-step. So for instance, I drop my pencil. For instance, if I have 3x minus 11 equals 22, I have 2 steps to this equation. I eventually do want my x to be by itself, but I want to do this in a certain order. And we're going to do this in opposite or reverse order of operations. So SADMEP. And what I mean by that is we have multiplication happening here. We have subtraction happening here. I want to take care of this part of the problem first, right? The subtraction part first. Any subtraction or addition that has to be taken care of first. So I'm going to add 11 to both sides. That's going to help me start isolating my variable. That's going to leave me with 3x equals 22 plus 11 is 33. Now be careful. we're going to divide by 3. Make sure that you divide. When I'm not subtracting 3, I'm dividing. 3 times what number equals 33? Well, 33 divided by 3 equals 11. So sometimes you have more than one step. You have multi-step equations. Let's look at another example. I'm going to make this one a little bit of a scary one. That's an 11. Now we got a bunch of stuff happening here. Before I can start solving, I need to follow my order of operations and I need to start simplifying. I have parentheses. I can't do anything inside the parentheses, so then I move to addition or subtraction. Multiplication or division. There is multiplication. I do need to distribute this number. So then I have 20 plus 8q, that is a q, minus 88 equals negative 12. I'm not finished simplifying. I have some like terms here. I have this 20 and I have this negative 88. I can't combine that with the q because they don't have a q, but I can combine the 20 and the negative 88. So then I have 8q and 88, negative 88 and 20 over here, right? They have different signs, so I'm going to subtract the numbers. So that's 8, that's 6. I'm going to use a sign of the larger absolute value. That's negative 88. So that's going to leave me with minus 68 equals negative 12. And now I have a two-step problem like I do over here, just larger numbers. I want to eventually get q by itself. I'm going to add 68 to both sides. That's going to leave me with 8q equals, and I'm going to change the way this looks to make my subtraction a little neater. So 8 minus 2 is 6. 6 minus 1 is 56. Now this is multiplication, so I'm going to do the opposite. And 56 divided by 8 is 7. All right, so there's your review. I'm going to go over the new thing now. So this is what you're going to have that's new, and then we're going to be done. Like I said, this is going to be pretty short. So now what we are going to do, and I'm going to give you a couple examples. Equations with variables on both sides. So we had equations with variables on one side for the last couple examples. Now we have them on both sides. So for instance, if I have something like x plus 16 equals 9x. I have variables on both sides. Little tricky to start out with because we were just trying to get x by itself. I am going to draw my balance line, but I'm not going to put the x at the bottom because I want to decide where I want the variable to go. Remember, in an equation, I can do anything I want to the equation as long as I do the same thing on both sides. So when I'm solving, I want to make things really simple for myself as well. I don't necessarily want to deal with a bunch of negatives and positives if I can make it easy. I don't want to deal with a bunch of decimals if I can make it easier, fractions, things like that. So I'm going to look at my x's. I need to get them to the same side of the equal sign. Now I can simply do that by, if I subtract x over here, that becomes 0, right? I'm going to write that lightly because we don't really need to write it. Plus 16 equals, now, since I did it to this side, I'm going to subtract x from this side. 9 minus, remember there's actually a 1 there, we just don't need to write it. 9 minus 1 is 8x. Now I have my one-step equation. I'm going to forget that 0. Divide by 8 on both sides. And I get my answers, x equals 2 or 2 equals x. I'm going to do one more of these examples for you. My next example is, let's not do a tough one. Let's do 4y minus 70 equals 12y plus 2. There might be two more examples for you. I want to get my y's to the same side of the equal sign here. I could subtract 12y from both sides, but 4 minus 12y gives me a negative 8y, which is okay, but I want to keep that positive. Just keeps that as something that it's less things I need to remember. So I'm going to subtract 4y from this side. Since I'm doing it to this side of the equation, I have to do it to this side. This is a big deal here. Don't forget the sign here. Then I get negative 70 equals 8y plus 2. Now I have a two-step equation. Subtract 2. This is negative 72 equals 8y. Divide by 8. Negative divided by positive is a negative 9 equals y. Finally, I'm going to do one more, a little bit involved here. Same as all the other equations that we did earlier, you might have a little simplifying to do. First thing here I need to do is simplify on this side. I need to distribute. And that is 5p plus 30. I need to get my p's on the same side. So it just so happens that every one I've picked, I've been moving them to the right side, but you can move them to the left side as well. In order to make this become 0, I subtract p. And then I get 30 equals, remember that's a 1 here. Sorry, not 1p, that was bad, 5. Glad I caught that. Subtract 5p from both sides. 8 minus 5 equals 3. Divide by 3, and I get p equals 10, or 10 equals p is my answer. That's it for your practice. Go through this, answer the questions, and then do your practice problems. All right, that's it.